guys, Mrs. Traver here. Today we're going to talk about sine and cosine ratios. Our learning target is that you'll be able to learn about sine and cosine, and we'll use that with our triangle toolkit. You'll be able to find each trig ratio at this point, that is sine, cosine, and tangent. Later we'll talk about angles. This is just the start of chapter 5. I'm excited to get going. Let's look at the first thing, which is tangent review. I want to look back at this. We did it last chapter. So as a reminder, tangent works with right triangles. So I've got a right triangle for us here, and I've marked this angle theta. That's that Greek letter that looks like a 0 with a line through it. We call that theta. And when we have theta, we can label our sides. Opposite, which is across from theta, hypotenuse, which is across from the right angle, and adjacent is the last side. Our tangent ratio is tangent of some angle, theta, is equal to the opposite side over the adjacent side. Here's an example of tangent to get us going. So I've got this triangle, and I want to label my sides first. Across from my reference angle, 27, is my opposite side, and next to it is adjacent. So if I trade these numbers out, instead of theta, I'm going to use 27. Instead of opposite, I'm going to use x, and instead of adjacent, I'm going to use 10. At this point, I can solve for x by multiplying both sides by 10. These will cancel on the right, and then we can type it in our calculator to see what we get on the left. So I've got my decimal scientific calculator here. I'm going to type in 10 tangent 27, which we get 5.09. The 9 will round up though, so this will be about 5.1. So x is approximately 5.1. Let's move forward here, do one more where we solve for the adjacent side. So on this one, I label sides. Across from 46 degrees is opposite, and next to it is adjacent. Can set it up and say tangent of my angle 46 is equal to the opposite side is 7, and the adjacent side is x. Now, x is on the denominator. In this case, we can switch the places of these two things to solve. So x equals 7 over tangent 46. And that'll go in our calculator. There it is. So 7 divided by tangent 46. 6.76 if I round. So x is approximately 6.76. So that's tangent. We've done that before. Let's look at a different triangle. And let's try these ones on your own first. So take a minute and pause this video. Try these two. Make sure you feel really good about tangent. All right, hopefully these went well for you. On the first one, you should have tangent of 27 equals x over 10. And this one, you should have tangent 38 equals 20 over x. To solve on this one, we would have done 10 on both sides. So x is equal to, let's see, 10 tangent 27. Oops, that looked crazy. Try that again. 10 tangent 27, 5.1. And the other one, I would have switched places and had x equals 20 over tangent 38. 20 over, oops, clear. 20 over tangent 38, 8, is 25.6. So there's your two answers to check. Let's move forward to something else. So the sine ratio is one we haven't talked about yet. If we label our sides like we know, the sine of theta is equal to opposite over hypotenuse. Now notice, if you say sine the long way, it's S-I-N-E, but when you write it, it's S-I-N. Similar to how tangent, if you write it out the long way, is like this, and you write T-A-N. Same thing goes for sine. So it's written as S-I-N-E, and in the formula we write S-I-N, but you say sine, like S-I-G-N. Wow, English is weird. Anyways, so this ratio is opposite over adjacent, and so we're using O now and H this time. So let's try some with the sine ratio. So here I've got the formula for us. Sine theta equals opposite over hypotenuse. Let's label our sides. Across from 25 is opposite. Across from the right angle is hypotenuse. So I've got sine of our angle is 25, so sine 25 equals x over 9. And just like we did with tangent, we'll solve the same way. Let's multiply each side by 9. So 9 sine 25 will be our answer. Let's type that in, clear it out. 9 sine 25. So 3.8 approximately. So x is approximately 3.8. Let's try another. with cosine. So cosine's the last one. It's written long way as cosine, like this, C-O-S-I-N-E, and you write it here as C-O-S. Do not say cos, though. It's cosine. Don't say cos. So this one is adjacent over hypotenuse. Same idea, different fraction. So let's do one of these ones. We've got our opposite and adjacent side. Actually, I'm going to give us one more number here. I'm going to make the x be here. There we go. We've got our adjacent side, which is here, and hypotenuse side. So I would use cosine of 25 equals x over 9 and multiply by 9 on both sides. So let's see what we get for this guy. We've got this time 9 cosine 25, so 8.16. All right. I want to try to look at this as a whole. So we have sine, cosine, and tangent now, and there's an acronym to help us remember. It's Socatoa. I don't know who came up with this, but it's a really easy way to remember them. So SOH is sine equals opposite over hypotenuse. CAH is cosine equals adjacent over hypotenuse. And TOA is tangent equals opposite over adjacent. So Socatoa is something that you will need to memorize how to spell. And if you can memorize how to spell these 9 letters in a row, then you know all of these formulas and how to set them up. So knowing this first thing here will give you all the rest. Let's try some on your own. At this point, step 1 is labeling sides. So label opposite, adjacent, and hypotenuse, and then figure out which one you're using before going ahead and solving it. Try these out and see how it goes first, and then we'll jump in and do them together. All right, hopefully you gave them a shot on your own first. Let's look at the first one. So across from my right angle is hypotenuse, across from my reference angle is opposite, and the last one is adjacent, but there's nothing there. So I really have an O and an H, and usually I actually don't write the one that I don't have. So I have an O and an H, which in this case is sine, O and H. So I'm going to use the sine formula, and I know the sine formula because SOA is right here, opposite over hypotenuse. So sine of our angle 34 equals opposite 13 over hypotenuse x. To solve when there's a variable on the bottom, we switch places, so x equals 13 over sine 34. Let's plug that in. 13 over sine 34 is 23.2. So x is approximately 23.2. Let's try the next one. And this one across from the right angle is the hypotenuse side. And here's my reference angle. Then one that's next to it is adjacent. So I have an adjacent and a hypotenuse. That is a cosine formula. So let's set ourselves up. Cosine of our angle is 20. Adjacent is x. And hypotenuse is 10. To solve, we'll just multiply both sides by 10. So we've got x equals 10 cosine 20 with our calculator. 10 cosine 20 is 9.39. That'll round up to 9.4. Oops, that looks like 914. Let's try that again. 9.4. The last one here, we've got an angle 45 degrees. Across from that is opposite, and next to it is adjacent. So I've got opposite and adjacent. This is a tangent one. So tangent of 45 equals opposite, which is x, over adjacent, which is 5. We'll multiply both sides by 5. So 5 tangent 45. Let's put that in and we'll be all set. 5 tangent 45 is 5. So x is 5. This is actually a special triangle. I want you to notice that these two are equal. So it's an isosceles. Whenever there's a 45 degree, that is a shortcut for you. Those two are equal because they're an isosceles triangle. One more problem for us before we go, and it's a story problem about San Francisco. While traveling around the beautiful city of San Francisco, I've never been there, but I'd like to go. One of the steepest hills, called Filbert Street, has a slope angle of 17.5 degrees. So I'm going to draw a hill here, or attempt to. So this is me drawing a hill, and its angle is 17.5 degrees. Once Janesha finished climbing 100 feet up the hill, so she climbed 100 feet up the hill. She wanted to know how high she climbed. So what was the actual height difference here? So I'm going to put an X there. Let's figure this out with our trigonometry. I know this is a right angle since the height works. And it looks like I have an opposite and a hypotenuse side. So this is a sine formula. I know that because of SOA. So sine of our angle, 17.5, equals opposite, or x, over adjacent, 100. I can multiply both sides by 100 to solve. So I've got 100 sine of 17.5. 30 feet. So she climbed 30 feet up on an angle. That's pretty high. Alright guys, that is all we've got for today. As a recap, remember you've got Socatoa. That is the big thing for us. I'll put it back on the screen here. Socatoa is what we're using for all of these problems. So if you can remember those 9 letters, then you'll be good to go. I will see you next time. Bye guys.